meet Mrs. Red, Mr. White, and platelets.
We're all here!
Hi! Pleased to meet you all.
Mr. Myoglobin, I'm the division chief of the Oxygen Transport Group. Can you tell me in a few words why you would be a suitable candidate for our team?
Certainly, Miss Red. I'm a globular monoprotein found primarily in the muscle, and I can bind oxygen molecules by delivered myoglobin. I'm capable of binding a single oxygen molecule.
I see. So you are not primarily found in the blood?
No. I'm interesting.
Thank you. Can you tell me a little bit about your structure?
Yes, contain a single polypeptide chain, and I'm built primarily of alpha helices and random turns. I contain a heme group, and it allows me to reversibly bind oxygen. My interior consists almost entirely of hydrophobic residues. The only charged residues I have inside me are the two histidines that play a vital role in binding of the oxygen. So, what is the mechanism by which you bind oxygen? It involves a bit of complicated chemistry. My iron can bind to 4 nitrogen atoms in the center of the protoporphyrin ring, leaving 2 free binding sites. One binding site binds to histidine, and the other is free to bind oxygen. The histidine prevents other larger molecules from entering the oxygen binding site, and makes the reaction reversible. So, what you're trying to say is that oxygen carrying capacity of 1 molecule of oxygen per the molecule of myoglobin. Yes, that's correct.
How does your structure differ from that of Mr. Hemo-Globin?
Confused hemoglobin is a tetramer compound of 2 each subunits alpha and beta. I'm a monomer. I don't have a quaternary structure at all.
So, in terms of function, how do you differ from Mr. Hemoglobin?
Well, sir, I can bind oxygen much more tightly than hemoglobin. That's why I'm well suited for binding oxygen in muscles. Additionally, I can act backup system for hemoglobin if you should suck it under the extreme conditions like exturation and exercise. When hemoglobin cannot supply enough oxygen to the muscles, I can take over, and because I'm able to bind more oxygen, store oxygen, I'm able to store it. Since I hold on to oxygen more tightly, letting it go it's not easy. As a result, I'm able to store oxygen reserves in muscle.
So what you're basically saying is that you don't release oxygen into the blood, but why?
I don't release oxygen into the blood because I have a higher oxygen or affinity for oxygen than myoglobin. Furthermore, the partial pressures of oxygen in mitochondria is much lower than blood, so that when I do give up my oxygen, the concentration gradients favor delivery to the mitochondria rather than blood. This property can be illustrated in a figure of graphs depicting my higher oxygen affinity when compared to hemoglobin.
Oh, now I understand. So you would be more useful in the environment of the skeletal muscle when hemoglobin is under excessive pressure.
That's correct, ma'am. We like to work as a team. Hemoglobin and my buddy, hemoglobin, carries the oxygen from the bloodstream, then passes some of it to me in the muscle cells for storage until it is needed in stressful situations, such as exercise.
So, as I mentioned, I'm the division chief of the Oxygen Transport Group. However, my deputy, Mr. Muscles, is responsible for recruitment to the oxygen and exercise branch of the division. Let me see if he's available to join us for the interview.
That sounds like a great idea.
Beep, 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 beep. Join the group for discussion. Mr. Muscles? Maybe not Mr. Muscles.
Wait.
Mr. Muscles, do you have any specific questions for the candidate? Since this is your area of expertise.
Absolutely. Thank you, Mrs. Red, for calling me. Now, Mr. Myoglobin, it is my understanding that you function primarily in the skeletal muscles rather than in the blood. Why is this?
Oh, well, as I explained before, the blood needs to be able to lose oxygen as it captures it. The whole point of take the oxygen to the lungs and then release it throughout the body. Blood that is really good at only capturing oxygen would be an oxygen trap. If I were present in the blood, I would not want to let go of the oxygen because I have a high affinity. That's why I take oxygen from hemoglobin and store it in the muscles for future use.
Good answer.
I have one last question for Mr. Myoglobin. Why do deep sea mammals have higher concentrations of myoglobin? Let's find out. Deep diving. Oh my gosh, deep diving is, I'm sure, what you're referring to, Mr. Playlets. Deep diving sea mammals undergo long underwater dives. In order to have enough stored oxygen to allow them to do this, they have to have a much higher concentration of usually, when proteins are highly concentrated in one place, they start to clump together, which stops them from functioning properly. In case of deep diving sea mammals, they have evolved variants of myoglobin, that are less likely to clump together because they have a higher charged surface that allows them to remain at high concentrations without losing function.
Good answer. Thank you for your time, Mr. Myoglobin. We will let you know our decision at a future date.
Thank you very much. I look forward to hearing from you guys.